March 6th, 1945, 10 in the morning. Cologne, Germany. Technical Sergeant Jim Bates of the 165th Photo Signal Company crouched behind rubble on Komödienstrasse, his 16mm camera rolling. Two M4 Shermans from F Company, 32nd Armored Regiment, 3rd Armored Division rumbled toward the cathedral, the twin spires rising above the shattered city. The lead Sherman never saw the trap. A Panther tank, commanded by Wilhelm Bartelborth, waited in ambush. Bartelborth held the honor roll clasp of the German army, awarded for exceptional bravery in combat. Two 75mm shells tore into the Sherman's turret in rapid succession. The gunner and driver died instantly. Second Lieutenant Karl Kellner, the tank commander from Sheboygan, Wisconsin, had his left leg blown off at the knee. He climbed out, clutching a carbine, collapsed on the engine deck, and despite a tourniquet applied by Stars and Stripes reporter Sergeant Andy Rooney, who held him in his arms, Kellner bled to death within minutes. Bates kept filming throughout. 3 of 5 crew members died. One street over, Staff Sergeant Robert Early heard the explosion and received orders to engage. His vehicle was not a Sherman. It was a T-26 E-3 Pershing, one of only 20 sent to the European theatre under a classified program called Zebra Mission. These new American heavy tanks had been rushed to Europe to test them against German armour. Early's gunner, Corporal Clarence Smoyer, age 21, rounded the corner and found himself staring directly into the Panther's gun tube. At that range, whoever fired first would win. Bartelborth hesitated. He had never seen a Pershing before, and momentarily mistook it for a German tank. That hesitation cost him everything. Driver Technical Corporal William McVeigh, known as Woody to his crew, kept rolling through the intersection rather than stopping, a decision that saved his crew's lives. Smoyer fired on the move. Direct hit. He fired 2 more rounds to make sure. The Panther burned for days, the flames visible against the backdrop of Cologne Cathedral. Bartelborth survived and lived to age 93. The footage became the most famous filmed tank engagement of World War II. Historians and military enthusiasts have studied every frame, but behind this single dramatic moment lay a larger truth that post-war mythology would obscure. The Sherman tank, mocked by critics as a death trap and dismissed as inferior to German engineering, had already proven itself the most effective medium tank of the war. Not because it was the best tank in any individual category, but because it was designed to win wars rather than battles. The Sherman embodied a different philosophy of armoured warfare, one that valued mass production, reliability, and strategic mobility over individual combat prowess. This is the story of how 49,234 Shermans changed the course of history, and how the tank that critics derided as a burning coffin became the vehicle that carried the Allied armies from North Africa to Berlin. The Sherman's origins trace to the fall of France in June 1940, when the world watched in astonishment as Germany's armoured divisions sliced through Europe's finest armies in just 6 weeks. French tanks actually outnumbered German panzers, and many were technically superior, but German doctrine, communications, and combined arms coordination made the difference. American military planners studied every report from the disaster and drew their own conclusions. The M3 Lee, then under development, was acknowledged from the start as a stopgap measure. Its 75mm gun sat in a limited traverse sponson on the hull side, an obvious compromise that left gunners unable to engage targets across their full field of fire. The tank was tall, awkward, and mechanically complex. American engineers knew they could do better, and the urgency of the global situation demanded they do so quickly. On April 18, 1941, the United States Armored Force Board evaluated 5 designs for a new medium tank at Aberdeen. The evaluation lasted less than a day. They selected the simplest option, understanding that in industrial warfare, simplicity equals speed. The winning design was designated T6. It married the M3's proven chassis and drivetrain to a fully traversing turret mounting the same 75mm gun. No revolutionary technology, no exotic engineering solutions. Just solid, practical design that could be manufactured by automobile companies with minimal retooling. The T6 prototype was completed on September 2, 1941, at Aberdeen Proving Ground in Maryland. Testing went smoothly. The tank was easy to drive, relatively easy to maintain, and performed reliably in trials. By October, The design was standardized as medium tank M4. Named for Civil War General William Tecumseh Sherman, the tank would soon carry that name into a new kind of industrial warfare its namesake could never have imagined. The first production, Sherman, an M4A1 with cast hull, rolled off the line at Lima Locomotive Works in Lima, Ohio, in February 1942. Just 5 months after Pearl Harbor, America had its new weapon. Within weeks, multiple factories across the country were tooling up for mass production. The arsenal of democracy was shifting into high gear. The Sherman's design was shaped not by what engineers wanted, but by what logistics demanded. This is the crucial point that post-war critics consistently overlooked. Army Regulation 850-15 restricted tank width to 103 inches and weight to approximately 30 short tons. These were not arbitrary limitations imposed by bureaucratic ignorance. They represented the hard physical constraints of global warfare. A tank wider than 103 inches would not fit on standard American railroad cars. It could not be transported efficiently across the continental United States to ports on both coasts. It would not fit in the holds of Liberty ships, the standardized cargo vessels that were being produced by the thousands to carry American industrial output across the oceans. The Sherman had to fit within these dimensions because America's strategy depended on building more tanks in Detroit than Germany could destroy in Europe. Weight mattered equally. A tank weighing approximately 30 short tons could cross existing Bailey bridges and civilian infrastructure throughout Europe. It could roll off standard landing craft onto invasion beaches. It could be recovered and repaired by standard military equipment. Every European bridge that a 33-ton Sherman crossed easily became a serious problem for a 57-ton Tiger. German heavy tanks often had to take long detours to find bridges strong enough to support them, and many were lost when bridges collapsed under their weight. The base M4 Sherman carried 50.8 mm of frontal hull armor angled at 56 degrees, with 76.2 mm on the turret front and a 76 mm gun shield on early production models. The angled armor was important because it increased effective thickness against incoming shells. A projectile striking at an angle had to penetrate more steel than one striking perpendicular to the surface. Combat loaded. The Sherman weighed approximately 33.4 short tons and stood 9 feet tall. Critics often pointed to this height as a disadvantage, making the Sherman easier to spot on the battlefield. Defenders noted that the extra height gave the crew more interior space to move around, making escape easier when the tank was hit. Each design choice involved trade-offs. American engineers prioritized crew survival. The Sherman carried a crew of 5 men who became intimately familiar with every inch of their vehicle. The commander sat in the turret, responsible for directing the tank, communicating with other vehicles and headquarters, and scanning for threats. Below and to his left sat the gunner, who aimed and fired the main gun and the coaxial machine gun mounted beside it. The loader sat to the right of the gun breech, responsible for keeping the weapon fed with ammunition. These 3 men rotated with the turret, always oriented toward the target. In the hull sat the driver on the left front, and the assistant driver, also called the bow gunner, on the right. The assistant driver operated the hull-mounted 30 caliber machine gun and assisted with maintenance. In emergencies, he could take over driving duties. 5 men working as a team could make a Sherman dance across the battlefield in ways that never showed in the specifications. The standard 75mm M3 gun was gyro-stabilized in the vertical plane, a feature no German tank possessed. This technology, adapted from naval fire control systems, allowed American gunners to maintain sight picture while the tank moved over rough terrain. The stabilizer did not guarantee hits while moving at full speed, but it dramatically reduced the time needed to acquire targets after stopping. In combat, seconds mattered. A crew that could fire accurately 2 seconds faster than their opponent often won the engagement. Testing showed the stabilized gun gave Sherman crews 70% hit probability at 300 to 1,200 yards while moving at 15 miles per hour. German tanks had to stop completely to fire accurately. This meant American tanks could dash between cover positions, firing suppressive shots that kept German gunners buttoned up and blind, then stop briefly for aimed shots before moving again. The tactic required skilled crews, but American tankers had time to train before deployment. Road speed ranged from 24 to 29 miles per hour, depending on the variant. With cross-country speeds of 15 to 20 miles per hour and an operational range of 100 to 150 miles on a full tank of fuel, these numbers mattered enormously in a war of movement. A Sherman could advance 40 miles in a day over reasonable terrain. German heavy tanks often covered less than 10 miles before mechanical problems forced a halt. The genius of the Sherman lay in its variance, which allowed the basic design to be adapted for different conditions and evolving threats without disrupting production or creating logistical nightmares. All variants shared the same basic chassis, suspension, drivetrain, and most mechanical components. A spare part for an M4A1 would fit an M4A3. A crew trained on one variant could operate any other with minimal reorientation. The M4A1 featured a distinctive cast hull, produced by pouring molten steel into molds rather than welding flat plates together. The rounded surfaces provided slightly better ballistic protection in some areas, and casting was faster than welding for large components. The M4A2 ran on twin General Motors diesels and went primarily to Lend-Lease allies and the Marines. The diesel engines were more fuel-efficient and reduced fire risk, but they were heavier than gasoline alternatives. The M4A3, powered by the superb Ford GAA V8 producing 450 to 500 horsepower, became the preferred United States Army combat version. The Ford engine was specifically designed for tank use, unlike earlier engines adapted from aircraft or trucks. It was powerful, reliable, and relatively easy to maintain in field conditions. Tankers loved it. The M4A3E2, nicknamed the Jumbo, packed approximately 102 mm of hull front armor, well over 180 mm effective when considering the angle. This armor could resist Tiger fire from the front at normal combat ranges. Only 254 Jumbos were built between May and July 1944 at Fisher Grand Blanc Arsenal, because the extra armor added nearly 12,000 pounds to the vehicle's weight. But crews loved them anyway. Jumbos often led columns into dangerous situations, absorbing hits that would have destroyed standard Shermans, while the following tanks maneuvered to engage. The M4A3E8, called the Easy 8 by crews who appreciated its smooth ride, introduced the wider-tracked HVSS suspension and the 76mm M1 gun. The horizontal volute spring suspension distributed the tank's weight more evenly, reducing ground pressure and improving mobility on soft terrain. The 76mm gun could penetrate Panther frontal armor at combat ranges, finally giving American tankers a weapon that matched German protection. 2,617 Easy 8s were produced by Chrysler, starting in August 1944. The British developed their own solution to German heavy armor by mounting the devastating 17-pounder anti-tank gun in a modified Sherman turret. The resulting vehicle, called the Firefly, he could penetrate 163 mm of armor at 500 meters with standard ammunition and 256 mm with specialized tungsten core rounds. The Firefly could defeat any German tank frontally, including the Tiger and King Tiger, at normal engagement ranges. Creating the Firefly required significant engineering work. The 17-pounder was much larger than the American 75mm gun, and fitting it into the Sherman turret required removing the assistant driver's position, redesigning the ammunition stowage, and reinforcing the turret ring. But the result was worth the effort. Approximately 2,100 to 2,200 Fireflies were converted, with 342 ready by the end of May 1944. German tank crews received explicit orders to engage Fireflies first whenever they identified them by their longer gun barrels, prompting British crews to apply elaborate camouflage to disguise their vehicles. Field modifications proved equally important in adapting the Sherman to conditions that designers had never anticipated. The Norman bocage presented one of the war's most vicious tactical problems. These ancient hedgerows on earthen embankments rose up to 15 feet high, creating a maze of small enclosed fields ideal for defenders. Shermans trying to climb embankments exposed their thin belly armor to Panzerfaust fire, while their guns pointed uselessly at the sky. German infantry with rocket launchers waited in every hedgerow. Sergeant Curtis Grubb Culin, the 3rd of the 102nd Cavalry Reconnaissance Squadron, attached to the 2nd Armored Division, solved the problem with scrap metal and ingenuity. He welded steel prongs from German beach obstacles onto a Sherman's bow, creating what became known as the Rhino hedgerow cutter. The prongs bit into the earthen embankments, allowing the tank to plough through rather than climb over. Demonstrated to General Omar Bradley on July 14, 1944, the modification transformed bocage warfare. Bradley immediately ordered mass production of the devices. Welders worked around the clock, fabricating thousands of Rhino attachments from captured German steel. By Operation Cobra, 3 of every 5 tanks in 1st Army carried the device. What one sergeant invented in a field repair shop became standard equipment within weeks. This kind of rapid adaptation was impossible in the German system, where modifications had to be approved through lengthy bureaucratic channels before implementation. 11 factories produced Shermans simultaneously across the United States. This distributed manufacturing approach was central to American industrial strategy. If bombing or sabotage destroyed one factory, 10 others continued production uninterrupted. No single point of failure could cripple the program. Chrysler's Detroit Tank Arsenal, a purpose-built facility of approximately 1.2 million square feet, designed by architect Albert Kahn, was the largest. The building itself was an engineering marvel, constructed in record time using mass production techniques. It produced 17,947 Shermans over the course of the war, and set the single plant record of approximately 900 tanks delivered in December 1942 alone. That was more tanks in 1 month from one factory than Germany produced Tiger ones in any entire year. Fischer's Grand Blanc, Arsenal built 11,358 Shermans. Pressed steel car, contributed 8,147. Pacific Car and Foundry, Baldwin Locomotive Works, American Locomotive Company, Pullman Standard Car, Federal Machine and Welder, Lima Locomotive Works, and Montreal Locomotive Works filled out the balance. These companies normally built railroad cars, locomotives, and heavy machinery. Converting to tank production required retooling but not reinventing their basic processes. The key to this success was standardization. All parts were fully interchangeable between factories. A transmission from pressed steel car would bolt into a hull from Fischer without modification. A tank assembled in Detroit used identical components to one assembled in Canada. Spare parts could be stockpiled anywhere and shipped wherever needed. This interchangeability extended to the battlefield, where mechanics could scavenge destroyed tanks for parts to repair damaged vehicles. Including M10 and M36 tank destroyers, M7 Priest self-propelled howitzers, recovery vehicles, and other Sherman chassis derivatives, total production on the Sherman platform reached 63,181 vehicles. No other tank design in history has approached this production volume. Lend-Lease distributed Shermans to allies around the world. Approximately 17,181 went to Britain, representing 34% of all M4s produced. The British became the Shermans' most enthusiastic users outside America, adapting the basic design to their tactical needs and developing the Firefly variant. 4,102 Shermans went to the Soviet Union, exclusively diesel M4A2s compatible with Russian fuel supplies. Soviet tankers generally appreciated the Sherman's reliability and crew comfort, though they considered it undergunned compared to their own T-34-85. 812 Shermans went to China, and hundreds more to France, Poland, Brazil, and other allies. German tanks looked fearsome on specification sheets. Every military museum visitor has stared at a Tiger and felt intimidated by its brutal appearance. The wide tracks, thick armor, and massive 88mm gun project, an image of invincible power. In combat, the picture was radically different. The Tiger I weighed 57 metric tons, carried 100mm of frontal armor, and mounted the legendary 88mm KWK 36L56 cannon. It could penetrate 112mm of armor at 1,400 meters, well beyond the effective range of the Sherman's 75mm gun. On paper, these specifications made the Tiger seem invincible. Reality imposed cruel limitations. Manufacturing each Tiger required enormous industrial effort. Early production Tigers cost approximately 800,000 Reichsmarks, when including all components and development amortization, though average chassis cost across the production run dropped to around 250,000 to 300,000 Reichsmarks. Factory assembly alone required roughly 100,000 man-hours, with the full supply chain figure reaching as high as 300,000 man-hours, when raw materials and subcomponent manufacturing were included. Only 1,347 Tiger Is were ever produced. Monthly production peaked at just 104 units in April 1944, representing the absolute maximum German industry could achieve under wartime conditions. The Tiger consumed approximately 430 litres of fuel per 100 kilometres on roads, and up to 675 litres per 100 kilometres in cross-country conditions. German fuel supplies were always precarious, increasingly so as Allied bombers destroyed synthetic fuel plants and advancing Soviet forces captured Romanian oil fields. Many Tigers ran out of fuel in their defensive positions and had to be destroyed by their own crews, rather than abandoned to the enemy. At 57 tons, the Tiger's weight meant most European bridges could not support it. Rivers that Shermans splashed across became impassable barriers for Tigers. Recovery after breakdown required 3 18-ton half-tracks working in concert, a logistical nightmare on a fluid battlefield. A substantial percentage of Tiger losses came from mechanical breakdown and crew abandonment rather than enemy fire. German crews learned to hate the machine they had been told was invincible. Its complexity made field repair nearly impossible. Its fuel consumption limited operational range. Its weight restricted movement. Its small production numbers meant that once a Tiger was destroyed, no replacement would arrive. The Panther, Germany's intended Sherman killer, weighed 44.8 tons. It featured an impressive 80mm glacis, angled at 55 degrees, approximately 140 mm effective against horizontal fire. It mounted the high-velocity 75mm KWK-42L70 cannon, one of the finest tank guns of the war. The Panther's combination of firepower, protection and mobility represented German engineering at its best. On paper, it was devastating. In reality, approximately 6,000 Panthers were produced. The Panther's combat debut at Kursk in July 1943 was catastrophic. Of approximately 184 Panthers operational at the battle's start, only about 40 remained running after 2 days. That attrition came overwhelmingly from mechanical failures rather than Soviet fire. Transmission problems, engine fires, and suspension failures destroyed more Panthers in those first days than enemy action. Final drives averaged just 150 kilometers before requiring replacement, confirmed by French post-war evaluation tests. The problem was endemic to the design. German engineers had pushed the Panther into production before working out these issues, and the problems were never fully solved. A substantial portion of Panthers lost in combat were destroyed by their own crews after breakdowns made them irrecoverable. The Tiger II, also called the King Tiger, epitomized Germany's wonder weapon fallacy. At 69.8 tons, the heaviest production tank of World War II, it used the same 700-horsepower Maybach engine that powered the 25-ton lighter Panther. This produced approximately 10 horsepower per ton power-to-weight ratio. The King Tiger could barely climb moderate slopes and was essentially immobile in mud or soft ground. Only 489 King Tigers were ever built. They arrived too late and in too small numbers to affect the war's outcome. The 103rd SS Heavy Panzer Battalion lost most of its 39 King Tigers to abandonment after mechanical breakdowns or fuel exhaustion, not enemy action. American and British tankers rarely encountered King Tigers, and when they did, air power and artillery often dealt with the threat before tank versus tank action became necessary. For every Tiger Germany produced, America built roughly 36 to 38 Shermans. Total Tiger I and Tiger II production combined, 1,836 units, equaled less than 4% of total Sherman output. Against approximately 40,000 Allied Shermans deployed in Europe by war's end, Germany fielded roughly 6,600 Panthers and Tigers combined. This represented a 6-to-1 ratio before accounting for the fact that only 30 to 70% of German heavy tanks were operational at any given time due to mechanical problems. German industry was crippled by multiple simultaneous catastrophes. Craft-oriented manufacturing traditions resisted the kind of standardization that made American mass production possible. Allied strategic bombing destroyed factories, disrupted transportation, and killed skilled workers. Chronic shortages of nickel and manganese degraded armor quality. Widespread sabotage by forced laborers and resistance fighters introduced subtle defects into critical components. The narrative that Shermans were uniquely flammable death traps is largely a post-war fabrication built on circular sourcing, a misleading bestseller, and selective memory shaped by decades of mythology that elevated German engineering while denigrating American. The nickname Ronson, supposedly from the lighter slogan that claimed it lights first time every time, has no documented wartime usage. This is not a minor point. Millions of pages of World War II military records survive in archives around the world. Every complaint about the Sherman, from inadequate armor to insufficient firepower to uncomfortable seats, appears somewhere in these documents. American soldiers wrote letters home, kept diaries, filed reports, and gave interviews. If Sherman crews had called their tanks Ronsons during the war, some documentary evidence would exist. None has ever been found, despite extensive searches by historians. The Ronson Company's actual wartime slogan was "Press it is lit, release it is out." The lights first time every time phrase appears in a December 1950 advertisement, years after the war ended. All World War II tanks burned at alarming rates when penetrated. This fact is thoroughly documented but rarely mentioned by those promoting the death trap narrative. British operational research data from Normandy showed 56.6% of Shermans burned after being knocked out, but Panthers burned approximately 63% of the time. Tigers burned 80% of the time. The numbers were broadly similar across all tanks of all nations, though German sample sizes in these studies were small. The cause was not the gasoline engine, since German tanks also used gasoline Maybach engines. The cause was ammunition propellant stowage. Early Shermans stored 75mm rounds in sponson racks along the hull sides, directly in the path of incoming shells. When a penetrating round struck these racks, the propellant ignited with devastating results. Studies showed approximately 80% of penetrations into the fighting compartment ignited propellant when ammunition was stored in these exposed positions. The solution was wet stowage, introduced in production starting January 1944 for the M4A1, 76mm variant, and February for the more common M4A3. Ammunition was relocated to the hull floor below the turret, the most protected area of the tank. Each round was surrounded by water glycerin jackets, concentric cells that when penetrated flooded the ammunition and prevented propellant ignition. The results were dramatic and immediate. Burn rates dropped from 60 to 80% down to just 10 to 15%. Crew casualties in burned tanks averaged 1.28 killed, while unburned tanks averaged 0.78 killed per loss. German tanks never implemented a comparable solution. Their ammunition remained stored in exposed positions throughout the war. This helps explain why Panthers and Tigers burned at even higher rates than Shermans. The death trap narrative owes much of its persistence to a 1998 book by Belton Cooper called Death Traps. Cooper served as an ordnance maintenance lieutenant, not a tank crewman, with the 3rd Armored Division's Maintenance Battalion. His job was recovering destroyed Shermans. This gave him an inherently biased sample of the worst outcomes. The tanks that performed well, survived combat, and kept rolling, never came to his attention. The burning wrecks were all he saw. Historian Stephen Zaloga revealed the book was Ghost, written by a game designer named Mike Benninghoff from Cooper's aging memories, without consulting primary sources. It contains numerous factual errors, including misidentified specifications and incorrect claims about various aspects of tank development. Brigadier General Albin Erzik, an actual Sherman tank commander who led armored units in combat, criticized Cooper's perspective as that of a rear-echelon functionary who never experienced tank combat firsthand. Nicholas Moran, known online as the Chieftain, systematically debunked the book's claims using Army archival research presented at Tankfest Northwest in 2015. The Sherman actually offered among the highest crew survival rates of any World War II tank. Later models had 5 escape hatches. The driver and co-driver had their own hatches on the hull roof. The commander had his cupola hatch. The loader had a dedicated hatch on the turret roof, and there was a hull-bottom escape hatch for emergencies when the top hatches were blocked by fire or debris. 5 ways out meant crews had options that their German counterparts often lacked. The relatively tall hull, often criticized for making the tank easier to spot, provided more interior space for crew movement during emergencies. A tanker scrambling to escape a burning vehicle needed room to move. The cramped interiors of German tanks trapped crews in moments when seconds meant the difference between life and death. Data from the Polish 1st Armoured Division showed that despite heavy tank losses, the division ended campaigns with surplus trained tank crews relative to available tanks. This seemingly paradoxical result, more crews than tanks, provides powerful evidence that crews regularly survived the loss of their vehicles. If Shermans were truly death traps, replacement crews would have been scarce. Instead, experienced tankers waited for new vehicles while their damaged mounts were repaired or replaced. The Shermans' combat debut came at El Alamein on October 23, 1942. Over 250 operational Shermans served with Montgomery's 8th Army against Rommel's Afrika Korps in the decisive battle that turned the tide in North Africa. The Sherman proved immediately superior to the Panzer III and early Panzer IV, the most common German tanks in theatre, and the British called it the best tank in the world. After months of fighting German armour with inferior equipment, British tankers finally had a vehicle they could trust. American crews first fought in Tunisia, where the painful lessons of Kasserine Pass from February 19 to 25, 1943, taught the United States Army that superior equipment meant nothing without proper tactics, reconnaissance, and combined arms coordination. 183 tanks were lost across the full campaign, including 46 of 52 Shermans in a single disastrous counterattack at Sidi Bouzid on February 15. German commanders, with years of combat experience, ran circles around green American units. But the American army learned fast. Within months, the same units that had been routed at Kasserine were driving Axis forces out of Africa. The Sherman got its crews to the fight. What they learned there prepared them for the campaigns ahead. D-Day, June 6, 1944, saw the Sherman DD swimming tanks attempt the deadliest mission of the war. These amphibious variants used inflatable canvas screens to provide buoyancy and propellers to provide thrust, allowing them to swim from landing craft to the beach. The concept worked in calm waters. The English Channel on D-Day was anything but calm. At Omaha Beach, the 741st Tank Battalion launched 29 DD Shermans into heavy seas, approximately 6,000 yards from shore, according to the battalion's own after-action report. The distance was too great, the waves too high, the screens too fragile. 27 of 29 sank, with most crews rescued by passing landing craft, though some men drowned entangled in their vehicles as the canvas collapsed. Only 2 tanks reached the beach under their own power. Those were commanded by Sergeant George Geddes and Sergeant Turner Shepard, who made it through a combination of skill and luck. The 743rd Tank Battalion's captain Ned Elder looked at the same seas and made a different decision. He wisely refused to launch his tanks into the water, ferrying them directly to the beach on landing craft instead. His entire battalion arrived intact and provided crucial fire support during the most desperate hours of the assault. At Sword Beach, where conditions were calmer and the launch distance shorter, 31 of 34 DD Shermans landed successfully. The contrast demonstrated that the equipment worked when conditions permitted. It was not a flaw in the Sherman design, but a command decision to launch in impossible conditions that caused the Omaha disaster. The Normandy bocage consumed weeks of grinding combat before Operation Cobra on July 25, 1944, finally broke the stalemate. The operation unleashed 1,269 M4 medium tanks after devastating carpet bombing that unfortunately struck American lines as well as German. Among the casualties was Lieutenant General Leslie McNair, the highest-ranking American killed in combat in the European theatre. The irony was bitter. McNair had been the architect of the tank destroyer doctrine that had delayed Sherman upgrades, insisting that tanks were not supposed to fight tanks and therefore did not need guns capable of defeating German armour. His death, during the very offensive that proved the value of massed armour, reinforced an important lesson about the danger of doctrinal rigidity in the face of battlefield reality. The bombing reduced the German Panzer Lehr division to just a handful of operational tanks. The breakout that followed demonstrated the Sherman's true strength. American armoured columns advanced at speeds that Panthers and Tigers, with their chronic breakdowns and enormous fuel consumption, simply could not match. The Sherman could sustain advances of 40 miles per day for days at a stretch. German heavy tanks were lucky to cover 10 miles without breakdown. The Battle of Arracourt, from September 18th to 29th, 1944, offers definitive proof that Shermans could defeat Panthers decisively when properly led. Combat Command A of the 4th Armored Division, including Lieutenant Colonel Creighton Abrams' 37th Tank Battalion, held a salient in Lorraine against the German 5th Panzer Army's 262 armored vehicles. 107 Panthers and 75 Panzer IVs were among them, along with 80 assault guns. No Tigers were present at Arracourt, despite some misidentification claims. On paper, the Germans should have won easily. Thick morning fog neutralized the Panthers' superior long-range optics, forcing close-range combat where American training and tactics prevailed. The Panthers' advantage lay in engaging at long distances, where their guns could penetrate Shermans, while Sherman guns could not penetrate them. In fog, that advantage disappeared. Captain Lamison of C Company, 37th Tank Battalion, arrived on a ridge position 3 minutes before 8 Panthers appeared. His Shermans knocked out 4 of the German tanks before they could return fire. They then withdrew over the crest, moved south, reappeared, and finished off the remaining Panthers. This aggressive, mobile style of warfare played to American strengths. Captain Jimmy Leach of B Company ordered his crews to mount tanks immediately, move guns blazing in line formation. The Panthers broke and ran. Over 11 days, Combat Command A lost 14 Shermans, while helping destroy 86 German tanks across the entire battle. The German force of 262 armored fighting vehicles was reduced to roughly 62 operational vehicles by the battle's end. The Battle of the Bulge, from December 1944 to January 1945, was, in historian Stephen Zaloga's words, the Shermans' shining moment. When Germany threw 1,400 tanks into the Ardennes in a desperate offensive, Sherman crews fought tenaciously in freezing conditions that tested men and machines to their limits. The most iconic moment came on December 26, 1944. First Lieutenant Charles Bogues led a column of 5 tanks, his M4A3E2 Jumbo nicknamed Cobra King at the front, through the village of Assenoir to relieve the encircled 101st Airborne at Bastogne. Abrams' 37th Tank Battalion, down to just 20 operational tanks, from a full strength of approximately 70, punched through German lines with characteristic aggression. At 4:50 in the afternoon, Cobra King made contact with the 326th Airborne Engineer Battalion. The siege of Bastogne was broken. Cobra King now stands in the National Museum of the United States Army at Fort Belvoir, preserved as a monument to the crews who drove toward the sound of the guns. The question of why American tankers entered Normandy with inadequate anti-tank capability has a clear institutional answer rooted in pre-war doctrine that events had overtaken. General Leslie McNair, head of Army Ground Forces from March 1942, championed a doctrine where tanks supported infantry and exploited breakthroughs. According to this doctrine, tanks were never supposed to fight other tanks. That role belonged to specialized tank destroyer battalions, equipped with fast, lightly armored vehicles, mounting powerful guns. Field Manual 17-33 from September 1942 devoted minimal space to tank versus tank action. This reflected official doctrine, not battlefield reality. American planners expected tank destroyers to handle German armor, while Sherman equipped tank battalions focused on supporting infantry and exploiting gaps in enemy lines. This doctrine created powerful institutional resistance to upgrading the Sherman's armament. The Ordnance Department began developing the 76mm gun M1 for the Sherman in August 1942, with testing at Aberdeen Proving Ground on August 1st and formal classification on August 17th. But the Armored Forces Board rejected full adoption in the spring of 1943, citing muzzle blast, an inferior high-explosive round compared to the 75mm, and concerns about vehicle balance. McNair told General Barnes he would never approve a heavy tank for the United States Army. When General Jacob Devers advocated for the T-26 with a 90mm gun, he had to go over McNair's head directly to General George Marshall. Marshall overruled Army Ground Forces on December 16, 1943, authorizing 250 T-26E, 1 Pershings. But bureaucratic resistance continued. Army Ground Forces tried to block the program again in November 1944, and Marshall had to override them a second time. The British solved the problem independently through determination that bordered on insubordination. Major George Brighty and Lieutenant Colonel George Witheridge pushed the Sherman Firefly conversion, despite official rejection by the Ministry of Supply's Tank Decision Board. They believed British tankers needed a weapon that could defeat Tigers and Panthers, and they found ways around official channels to make it happen. Prime Minister Winston Churchill himself made Firefly production a priority as D-Day approached. By the end of May 1944, 342 Fireflies were ready. The British even offered the Americans 200 complete Firefly conversions per month, an offer that was inexplicably allowed to lapse without acceptance. The real combat data challenges the fundamental assumption that German tanks posed the primary threat to Allied armour. British post-war analysis of tank losses in northwest Europe told a different story than popular mythology. German tanks accounted for only 14.5% of Allied tank losses. Self-propelled guns, mainly S-2G3s, caused 24.4%. Towed anti-tank guns caused 22.7%. Mines destroyed 22.1%. Panzerfaust and Panzerschreck infantry weapons caused 14.2%. The dreaded Tiger encounters that dominate popular imagination were extraordinarily rare in actual combat. American Shermans may have engaged Tigers only a handful of times across the entire European campaign. Tiger phobia was so widespread that Allied crews routinely misidentified Panzer IVs as Tigers, leading to wildly inflated estimates of Tiger numbers in theater. Staff Sergeant Lafayette Pool of Odom, Texas, became America's tank ace of aces through 81 days of relentless combat. A former boxer who once fought an exhibition against Joe Louis, Pool commanded the Sherman named In the Mood with 3rd Platoon, Company the 1st, 32nd Armored Regiment, 3rd Armored Division. From June 27 to mid-September 1944, Pool destroyed 12 tanks and 258 armoured vehicles and self-propelled guns. He killed over 1,000 German soldiers and captured 250 prisoners. His crew remained intact through 3 successive tanks, all named In the Mood, wearing out vehicles without losing a man. 3 Shermans, 1 M4A1 and 2 M4A1 76W variants, carried Pool and his crew through their remarkable combat record. When his 3rd Sherman was finally knocked out breaching the Siegfried Line, a shell fragment nearly severed his right leg. Pool attempted to cut off the mangled portion with his pocket knife, self-injected morphine, and told rescuers to take care of his tank. His devotion to his crew and his vehicle was absolute. His crew represented the diverse Americans who fought in Shermans. Driver Corporal Wilbert Richards, nicknamed Red or Baby, stood 5 feet 4 inches tall and could parallel park that big Sherman in downtown New York. Gunner Corporal Willis Oller, nicknamed Groundhog, could shoot the eyebrows off a gnat at 1,500 yards. Loader T5 Delbert Boggs was nicknamed Jailbird. Assistant driver Private First Class Bertrand Close, nicknamed Schoolboy, was just 17 years old. When the 3rd In the Mood was destroyed, Gunner Oller was not aboard, having been temporarily transferred stateside. His replacement, Private First Class Paul Kenneth King, was killed in the action. The rest of the crew survived the war. Pool was twice recommended for the Medal of Honor, but never received it. He inspired the character War Daddy, played by Brad Pitt, in the 2014 film Fury. Creighton Abrams remains the most celebrated American tank commander of World War II. Commanding the 37th Tank Battalion, 4th Armored Division from his Sherman named Thunderbolt, he went through 6 or 7 successive tanks bearing that name depending on which sources are counted. He wore them out mechanically without ever having one shot out from under him. His aggressive tactics kept German defenders off balance while preserving his own force. His gunner, Corporal John Gatuski, knocked out more enemy tanks than any other gunner in the battalion by universal agreement. The partnership between commander and gunner was crucial in tank warfare, and Abrams and Gatuski formed one of the deadliest teams of the war. General Patton's assessment was characteristically blunt. He said he was supposed to be the best tank commander in the army, but he had one peer. Abe Abrams was the world's champion. Abrams earned 2 Distinguished Service Crosses, one on September 20, 1944 for Arracourt, and one on December 26, 1944 for Bastogne. He later commanded Military Assistance Command Vietnam and served as Army Chief of Staff before dying of lung cancer on September 4, 1974, at age 59. In 1980, the Army named its new main battle tank the M4 Abrams in his honor. The 761st Tank Battalion, known as the Black Panthers, produced its own legend against the additional burden of fighting racism within their own army. Staff Sergeant Reuben Rivers of Company A drove an M4A3 Sherman with the 76mm gun. Near Gebling, France, on November 16, 1944, Rivers' tank hit a mine that slashed his leg to the bone. He refused morphine and evacuation, took command of another Sherman, and fought for 3 more days. On November 19th, spotting German anti-tank positions, Rivers radioed that he saw them and they would fight them. He charged. His tank was hit, and he was killed. Rivers was posthumously awarded the Medal of Honor on January 13, 1997, by President Clinton, one of 7 African-American World War II soldiers honored that day, after a Department of Defense study found racial discrimination had denied black soldiers the award during the war. British Firefly gunner Trooper Joe Ekins of A Squadron, 1st Northamptonshire Yeomanry, likely killed the most famous German tank ace of the war. On August 8, 1944, during Operation Totalize, Ekins destroyed 3 Tiger tanks in approximately 12 minutes during the early afternoon engagement. Tiger 007 was commanded by S. Hauptsturmführer Michael Wittmann, whose Tiger company had devastated the British at Villers-Bocage 2 months earlier. Wittmann had been promoted from Obersturmführer around June 21, 1944, just weeks before his death. The historical consensus leans toward Ekins as Wittmann's killer, though the Sherbrooke Fusiliers Regiment of Canada presents a credible alternative claim. Wittmann's body was not discovered until March 25, 1983, and was reinterred at the German military cemetery at La Cambre. The Sherman's post-war career lasted longer than most Cold War designs. In Korea, from 1950 to 1953, 679, M4, A3, E8, Easy 8s formed the backbone of American armor. They claimed 47 T-34-85 kills while losing 20, a notable achievement against a tank that had been designed a decade later. Israel's relationship with the Sherman became the longest tank love affair in military history. Beginning with a single tank secretly obtained as the British Mandate ended in May 1948, Israel eventually acquired approximately 620 Shermans and created remarkable upgrade variants. The M50 mounted a French 75mm gun from the AMX-13 light tank, starting around 1956. The M51 mounted a shortened French 105mm gun, the same weapon as the AMX-30 main battle tank, starting around 1965. Both variants fought in the 1956 Suez Crisis, 1967 Six-Day War, and 1973 Yom Kippur War. In 1973, M51s, armed with high-explosive anti-tank ammunition, scored kills against T-54, T-55, and T-62 tanks, designs that postdated the Sherman by 2 decades. Israeli Sherman chassis served as self-propelled artillery, ambulances, recovery vehicles, and other specialized roles well into the 1980s. Chile's modified Shermans, M50s, and M51s, purchased from Israel in the late 1980s, were among the last fighting Shermans in active military service. They were finally retired around 1999, approximately 57 years after the first M4 rolled off the assembly line at Lima Locomotive Works. The modern reassessment of the Sherman, led by historians like Stephen Zaloga and researchers like Nicholas Moran, has reached a clear consensus that overturns decades of popular mythology. The Sherman was not a perfect tank. It was something more important, a war-winning weapons system. Its gyro-stabilized gun, powered turret traverse, synchromesh gearbox, and fully interchangeable parts made it arguably the most technologically sophisticated medium tank of the war. The Tank Museum at Bovington in England noted it might be the only World War II tank where quality was not sacrificed for quantity. American engineers achieved both. The real comparison was never Sherman versus Tiger. It was the entire Allied combined arms system against the German military machine. Shermans, supported by P-47 Thunderbolt fighter bombers, massed artillery, infantry with bazookas, and M10 and M36 tank destroyers, all fed by an inexhaustible logistics chain that stretched from American factories to European battlefields. This system faced isolated German tanks operating with minimal fuel, degrading ammunition quality, green replacement crews rushed into service without adequate training, and no air cover against relentless Allied air power. The contest was never even close. A 1954 United States Army Ballistic Research Laboratory Study, Memorandum Report, 798. Analyzing 30 Sherman versus Panther engagements from the 3rd and 4th Armored Divisions, found the Sherman achieved a 3.6 to 1 kill ratio against the Panther. The supposedly superior opponent lost nearly 4 tanks for every Sherman destroyed in actual documented combat, though this ratio was heavily influenced by Panthers attacking dug-in Sherman positions rather than reflecting pure hardware superiority. At Arracourt, Combat Command A traded 14 Shermans for participation in destroying 86 Panthers and Panzer IVs. The myth of the 5-to-1 ratio, that it took 5 Shermans to kill 1 Panther, originated not from combat statistics, but from the fact that 5 was the basic tactical unit of American tanks sent together. Historian Stephen Zaloga has demonstrated this ratio has no basis in the historical records. The men who crewed Shermans, Pool, Abrams, Rivers, Smoyer, Ekins, Boggess, and tens of thousands whose names never made history books drove a tank that got them to the fight. It kept running when Panthers broke down. It gave them a fighting chance of climbing out alive when the worst happened. That was what mattered. That the Sherman served for nearly 60 years across 6 continents, from El Alamein to the Golan Heights, is the ultimate vindication of its design philosophy. No other tank design has matched that record of longevity and global service. Germany built the best tank. America built the tank that won the war.